So today we combine evaluating expressions with graphing. Now, if graphing lines is still an issue with you, that is something that has to get fixed now, because otherwise this is going to drive you insane, especially when we stick in this section for a couple days here and just try to feel our way through it. So what we're going to do here at the start is we're going to start with the basic idea of just working through the evaluating a piecewise function, and it's like what it says. Instead of having just a straight line, we're going to have a gap in there somewhere. So like a business application sometime is, once I've sold this many of a product, my profit starts to go up, or my costs start to go down, and things like that, and we can graph those. So what we're going to do is we're going to work these piecewise functions, and here's how they work. You're going to be given a function, something like this, where you've got two expressions with a conditional after it, an if statement. So here's the order we're going to take things in. I always need to look at the if statements first. Okay? This tells me which expression to use. And we'll take a look at one of these at the start just to kind of see how this is going to go. So if I'm looking at my if statements, it says, the first one says if x is less than or equal to 4, and the second one says if x is greater than 4. Well, any number is only going to fit into one of those. So we're not going to be plugging in our x value to both expressions. We're only going to plug it into the one whose conditional, whose if statement goes along with it. So for instance, for this first one, if x equals 10, which one of my if statements, if I plug in 10 for x, does it make true? The second one, because 10 is greater than 4. 10 isn't less than 4. 10 is greater than 4. So once I know which one works, we're going to substitute into the true statement, but only the true statement. So in this case, since the true statement's the bottom one, because when I plugged it in, 10 is greater than 4, I'm going to go, okay. So I'm just going to write bottom here, just to remind me it's the bottom one that I'm going to plug into. You don't have to do that, but I like to, because when I go back later, I can figure it out. So I got 2 times 10 plus 7. I literally just substitute whatever the x value is in. And then I simplify it and get my answer. So it's just really more of a complex substitution. It's figuring out what the statement is first, then figuring out where to plug it in. So I look at the next one. I go, okay, let's see. X is negative 1/3. Which statement does negative 1/3 make true? The first one, because negative 1/3 is less than 4. Okay, so this time I'm working with the top one. Same idea though. Replace the x with the value and solve it. And again, the nice thing on this one is, well, those 3's basically cancel each other out and just leave me with negative 1 minus 1. And if I wasn't sure, I could plug it into the calculator, but I think you got this. And I get my value. But it always has to be done in the order we have at the top. If statement first to figure out which one to use, and then use that one. Okay, so 3. Ooh, careful. X equals 4. The first one. Because 4 isn't greater than 4. 4 isn't even less than 4, but 4 is equal to 4. So we're back to the top again. So 3 times 4, because that's my x value, minus 1. And I'm set. And that's the whole gist of this whole thing. It's just go through, look at this, negative 2. Negative 2 is less than 4. My gosh, these are all at the top. Plug in my x value where the x is at, if I can. Negative 6 minus 1 is negative 7. Now, one thing I will make mention of here Because sometime you may either look in the book for an answer or something will come up somewhere. You may find somewhere, like if you looked in the back for this one, here's how the answer would be written. And basically what they're saying is you're taking the function, plugging in an x value of -2, and this is the answer you get. Okay, that's the proper way to write it mathematically. Just like here, it would be f of 4, whatever the x value is, equals my solution. So I just want you to be aware of what that can look like so you don't see it sometime and go, well, wait a minute. Am I supposed to be like solving this for effort? No, that's just a way of signifying that's the value at that particular function. Okay? Now, will there always just be one? No. As you sort of move down a little, you're like, oh, f of x, g of x, h of x. Ooh, 2 things to figure out. 1, which function am I using? And then 2, where do I plug in? Well, luckily for us, we just pay attention. We're like, oh, the first 4 all have f's. So 1 through 4 are all going along with this one. Because I see the f, that tells me the function that it's working with. Just in the same way that when I'm looking at 5 through 8, they all have g's in the front. There's my g of x's. Okay, worst thing you can do on one of these is have that happen to you where you're like, ooh, you're plugging it in the wrong one. 9 through 12, I'll have h's, so we're going to be using h of x for those, but only that. So when I'm doing 1 through 4, I don't care about these. Now this is the part that gets fun. So number 1, like, okay, I know, have to look at the if part first. Okay, if x is 2, and that's what this is saying, which one? The second one, because 2 is greater than 0. You're like, okay, but well, wait a minute. Where do I plug the x in? There's no x there. You don't. That's the value. It's just 2. If you don't have a place to plug your variable, you just write down the number that it is, and that's all you can do. So you're like, so all 4 of these, the answer is either going to be 2 or 3. Yes. It will look kind of weird if you look at it graphically, but yeah, that's the way it is. Okay, number 2. So really all we got to figure out is which one fits. Where does -4 fit? Okay, the first one, which means it just equals 3. Okay, so, and then we just kind of, one more. What the heck, and then we'll move to one where we actually get to plug something in. What's 3's answer going to be? 3. Because again, 0 isn't greater than 0, 0 isn't less than 0, but it is equal to. So that one's going to be 3. And that's all we're doing with these. It's substitution based on this. Okay, so we're to the g's now. So g of 7. So if I plug in 7 for x, which one are we playing with? The second one, because 7 is greater than 3. So I plug in the 7 where the x is at. 14 minus 1 is 13, and I'm good. Let's see here. 0. 0 is less than 3 last I checked. So it's just 0 plus 5, or 5. And you're like, okay, I kind of see where this one's going. But again, don't get careless. Because again, if you get a negative, like you do for number 7, g of -1, you're like, well, that's less than 3, okay. But don't forget that that's negative. That's the thing I see people do most often on ones like this. They'll see a negative number and they'll completely forget about the fact it's negative. Got to have attention to detail. All those little half pointers can get you after a while. You're starting to go, all right, I can handle this stuff. All right, let's do a couple in h here. I just want to make sure we're going all right. H of -4. Okay, here we go. Top or bottom expression? Top. Because -4 is less than 2. I'd rather owe somebody $2 rather than 4. So this one's the top. So when we plug that in, And again, take your time when you're thinking about these. Half of 4 is 2. And negative 2 minus 4 is negative 6. And again, that's my h of negative 4. Oh, let's see here. Let's jump down to 12. We'll hit a little of both here. H of 6. 6 is greater than negative 2. So we're looking at the bottom on this one. And again, just follow what's there. But be careful you're following order of operations. Don't do 3 minus 2 first. 1 times 6 is 6. Don't do it. 2 times 6 is 12. Then you can subtract, because subtract comes after multiply. Careful, careful, careful. Okay, now's where the fun starts. Okay. Graph the following functions. We are now going to combine what we just learned up here with graphing lines. From this point on, I am going to make the assumption that we can handle this whole thing with graphing lines. I will show on one of these a way to avoid it, but it's going to take some extra work, and I think you're just going to want to, after some time, do it the way I'm going to. If you do not have a pencil right now, watch this first, because we're going to be doing some erasing. Because here's how this is going to work. We're going to do 2 steps here. We're going to graph each line. Then we're going to erase the part we don't need. You're like, what? Don't need part of a line? Okay. The one that doesn't apply. Okay. I guess I should write it that way too. That does not apply. That's a much more mathematical way of saying it. So basically what we're going to do is we're going to graph 2 lines. We're going to figure out what piece we need according to the if statement. And we're going to erase the rest of it. So these graphs are going to look kind of funky. The one other thing I'm going to make mention of here, and I've got it on the board too, if you have an or equal to, okay, when we're doing it on the graph, we're going to signify that by having a really dark shaded in dot. If it's just less than or greater than, our endpoint's going to be an open dot. And that'll make a little more sense here in a minute when we actually do it on this first one. So we're looking at it, we're like, okay, so Harty, what's the deal? First deal. Okay, we're going to graph the first line. Don't graph them both right away, just the first one. So my y-intercept's at -1. Remember, y-intercept. -1. All right, get me a dot. Then my slope, remember, if it's not a fraction, I can always make it a fraction by putting it over 1. So from here, I'm going to go up 2 and right 1. And for at least this first time, I'm going to keep going until I run out of room. Just so we're going to be able to understand our concept here. Now, once I run out of room going to the right, I still could make my line go further going to the left by doing the opposite. So since to go to the right, I was going up and right, now to go the other direction, I'm going to go down 2 and left 1. And the result each time should always be a line, a straight line, not a curve. If you get a curve, something went wrong somewhere. So you're like, okay, I got all these dots. So did I just connect all the dots now? Almost. We got to figure out which part of the line we need. So I go back and I look, and I say, okay, it says right here, if x is less than or equal to 1. All right, here's my x-axis. Here's where x equals 1. There's my point, my value when x is 1. Since it's or equal to, this is going to be a big old colored in dot right here. Which direction do I go if I want the x values that are less than or equal to 1? Do I go to the right or the left? Left. So all the dots that go to the left, I'm going to connect and put my arrow on the end. And all the dots that I plotted to the right, bye. Because this says this line is true only when x is less than or equal to 1. Okay? Here's 1. Here's all the values that are less than that. So whenever you see less than, you're going to be taking all the points to the left of that value. So now I'm going to do the exact same thing with the second line. Now when I'm doing them for you guys, I'm going to switch colors, but I'm not going to switch colors until I'm actually done doing my graphing, because I'm going to have to erase part, unless I just get brilliant at this. So here we go again. Y-intercept at 1. Okay, put a dot. And then my slope is up 3 and right 1. So up 3 and right 1, up 3. And some of you may get to a point where you can look at the if statement and they're starting figuring out what dots you even want to do or don't, but we're not quite there yet. So since I went up 3 and right 1, to keep dotting the other way, I can go down 3 and left 1. Down 3, and some of you are like, uh-oh, it's the same dot. It's already on the other line. That's okay. Down 3 and left 1. So I can see these real easy. These are a little trickier to see, but I can still see them. But let's see what we need. If x is greater than 1, so my first job, okay, here's where x is 1. Here's my dot on the line I just made that has an x value of 1. Always can come back down to the x-axis if I'm not sure. Is this dot, this value, going to be open or closed? Open, because there's no or equal to. So I'm going to put an open circle there. And if my x values are greater than 1, which direction am I going to be getting my points from? Right. To the right, because that's where the x values get bigger. So I connect the dots going to the right, and any of the dots that I had made for this line that go to the left of where I was get erased. And that would be my piecewise function. Just says my values change depending on where we're going here. Maybe a store has a deal that'll give you a discount if you buy more than one of something. Okay, here they go. But if I buy less, who knows? But it's going to be different for each of these. Now, if you desperately are still at a point that you're like, yeah, me and graphing lines still don't get along. Okay, I'm going to show this once. Here's going to be your other option. Even though graphing lines is kind of critical, what you could do is you could bring up the graphing function. What you would do then is you would type in the expression that you're going to use. Now, normally you just hit graph and you see the line, but you're like, yeah, but you just said I don't need the whole line. That's true. So what you would do instead is you'd hit second graph, and you'd look at these and you'd say, okay, so for 1/2 x, x is less than 1. So the values of x to the left that get more negative. So for instance, I'd have 1, 0, -1, -2, and so on. So I'd say, okay, I'm going to look at the values on here for this, and I'm going to plot my points this way. I'm not going to draw the entire line. I'm just going to plot the points I want. So I want to point at, let's see here. So 1.5, which I see is an open circle. And then at 0, come back down so we can see them as I go. So 0, 0, and then I can go to -1, -1/2. And I can just plot my points, connect the dots, and be done. Now, you can do this. I'm not a proponent of it because, well, it's important to know how to draw a line. But we got to find ways to do things if we're having issues. And then I'd just do the same thing with the other one. I'd go back to y equals, but you notice this is taking me a little longer than it did just drawing my lines. Second graph. Greater than or equal to 1. I want them to the right, but I still start at 1. I'd have a closed circle because it's or equal to. And then again, bless you. Since I want the values to the right, I want values that are greater. 2, 1, 3, 0, 4, -1, and go. And I'd get the exact same thing if I just drew each of these lines and then erased. Okay. Either one works. I get the right answer either way. But again, this is going to be more time consuming if you have to go to the calculator every single time. But again, whatever it takes to get the job done is what we need to do. So let's take a peek here. Again, let's keep playing the draw, line, and erase game here, because I think that over time is you're gonna be much happier about this. Again, this tells me each of my lines are gonna start at 3, but initially I plot my y-intercept. Again, that first point typically is gonna be on my y-axis. What number's in front of x if I don't see one? 1. So 1 over 1. I don't just want to see a vertical line here. It's up 1 and right 1. So you're like, okay, this dotting thing is going to drive me crazy. Is there a way to avoid having to do all of this? There is, because once you get the hang of it and you start making dots, you'll start looking, you'll say, hey, wait, greater than 3. Okay, I'm only going to want the dots that are to the right of 3. Here's where x is 3. There's my dot. Okay. It's just greater than, so I know that's going to be open. So let me erase that because I want to make sure this is open. Open. And to the right. Okay. So see, if I'd have sat here and made all the dots all the way down here, I'd just erased them anyway. So, all right. So I've got the first one ready to go. So then I look at the next one. Okay, same type of idea. My y-intercept at -3. And then here goes the up 1 over 1 thing again. But I'm going to be careful this time. I know I got to get to 3. But then I'm like, okay, less than or equal to. Less than means I want the points to the left. Well, good, I already have those. I don't need to keep going. I know this is going to be a closed circle because it's or equal to. So make me a big old dot here on 3 because that's where I start. And I want all the points to the left. So I'll just play connect the dots. Again, don't make life hard on yourself. Don't do it, don't do it, don't do it. So let's see here. I think we need to take a peek at one more. Because then I got to show you one other fun little thing to do, but then we'll be okay for now, I think. But if something's bothering you, if you're like, wait a minute, now what exactly are you doing again? Let me know, because I want to make sure we get this fixed. Ooh, I don't see any number on the end. What's my y-intercept if I don't see one there? 0. Start here at 0. Again, if it's not a fraction, remember that it is. Okay, up 2 and over 1. Up 2 and over. Whoa, I better check here. If x is less than or equal to 1, less than is left. Okay. Starting at 1. Here's 1. Here's my point. It's going to be closed. Okay, big old dot. Left. Ooh, then I better keep going this way. Down 2 and left 1. Okay. Once I get a couple of points to work with, I'm okay. And if you want to make all the dots and you're comfortable that way and then you want to erase at the end, that's okay. I'm not going to tell you that's a bad idea. And then I just run the game again. Up 2, that's my y-intercept. Up 1 and right 2. Up 1 and right 2. Up 1 and right 2. and I go, I'm like, okay, so if x is, now what do I do here? Because I have a dot at x equals 0. I have a dot at x equals 2, but I don't have a dot at x equals 1. Well, now what am I supposed to do? If that happens, here's how we just fix it to make sure. I'm going to literally take 1, and I'm going to plug it into the expression. I need to know that exact point. So half of 1 is a half, plus 2 means we're at 2.5 when x equals 1. That's going to be my y value. So, and it looks like it's going to be open. So at 1, 2.5, when I have an open circle, you can see how this gets a little squished at times. So an open circle at 1, 2.5. And then I want all the values to the right of that. And again, it'll always be an open or closed dot and then an arrow at the other end. We will never have arrow straight through. Won't happen. We'll never have dot on both ends. At least today we won't. Okay? Won't happen. But that's what we're trying to deal with on these. So there's a couple of things to keep track of, but I got confidence in you. The only other thing we got, there's always got to be one additional twist. Write a piecewise function for the graph. You're like, wait a minute. So now I got to look at the graph and come up with something like they've had for all these original problems. Yes. So here's how this is going to work. We're going to do a process again. So I'm going to move this over a little for a minute so we can get this down. It's only 2 steps. Okay, first is, what is the if statement? Because you'll notice on all of these, there's a central point that we're working around. Like for instance, if we look at 15 and 16 for a second again, you look at your ifs, they both had to do with 3. Guess where your initial dots were? They were at 3. Your ifs here were x's and 1's. Your initial dots are at 1. So if you're given a graph, you look and you're like, okay, where's my initial dots? Well, they're at -3. So it looks like I'm going to have an if x is closed dot to the right greater than or equal to -3, which goes along with this guy, closed dot to the right. Then I've got my other one, if x is open circle going to the left if x is less than -3. Okay, that's my first part of figuring this out. Once I know that, then I have to figure out the y equals mx plus b form, the slope-intercept form of the line. And we've done that before. We looked at lines and figured out what the slope-intercept form was going to be. So here's how that works. Sometimes it's going to be easy, sometimes it may not be. Like for instance, on this line, I see that it goes through there at 3.5. Okay, so I know that part. But then my slope, remember, I just have to have 2 points to work with. Well, I have an end point, and it looks like this point is on the line as well. So to figure out my slope, I go up 1 and right 2. So my first equation is 1/2 x plus 3.5. There's my y-intercept, and if I keep going up 1 and over 2, I keep getting points that are on the line. Now the next one's a little trickier. You're like, well, I can figure out the slope, because here's a point and here's a point, so it looks like I'm going down 1 and left 1, but wait a minute, down and left. -1. What's a negative divided by a negative going to be? Positive. So I have positive x, but then I'm looking and I'm going, okay, if I can't see the y-intercept, can I get there? Sure. So if I'm going up and over, up and over, up and over, up and over. I can keep working my slope until I get back to the y-axis, and it's rated 2. Put my plus 2 on there, and I'm good to go. So just a reminder, we'll put this in writing. If you can't see the y-intercept, just go slope until you get to the y-axis. So here we weren't even close to the y-axis, but we just kept going up 1 over 1, up 1 over 1, up 1 over 1, and we finally got there. Okay? So your task today is this guy. And there will be some work time that gets blended in this week, but that doesn't mean put this off. Especially with the graphing, you need to do a couple of those sometime within this day of September 3rd. Because if you wait until September 4th, you are going to forget too much. So please, 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 make sure that you've at least tried some before we get going tomorrow. And I will